Have you ever been listening to a movie or a documentary and you hear a pilot talking to air traffic control? It's this rapid-fire stream of numbers and jargon that sounds like a completely different language. But what if I told you it's not a secret language at all? It's actually a brilliantly simple system. Come on, let's crack the code behind the numbers of the sky.
Yeah, you'll hear something just like this. And for most of us, it's just total gibberish. I mean, what in the world is a squawk? And why would you say 10,000 instead of just 10,000? It sounds way more complicated.
It really does sound like a secret code, doesn't it? But stick with me here for just a couple of minutes. I promise, by the end of this, you won't just understand that sentence. You'll get the whole system behind it. And the secret, as you'll see, is all in the numbers.
So, the first thing we have to get straight is that this language was never designed for secrecy. In fact, it's the total opposite. It's all about 100% absolute, undeniable clarity. In aviation, safety isn't just a goal, it's the only goal. And clear communication is the foundation of it all.
I mean, just try to imagine it. You're in a cockpit that's vibrating, you've got engine noise all around you, and you're listening for vital instructions through a radio that's filled with static. In an environment like that, mishearing 5,000 feet as 9,000 feet isn't a small mistake, it's potentially catastrophic. There is absolutely zero room for error.
And this is what brings us to the core of the whole system. This is the big aha moment. To get rid of any and all confusion, the world of aviation decided to pronounce a few numbers just a little differently than the rest of us. It all starts with how they say three specific digits.
Okay, so most of the numbers are pronounced exactly like you'd think. 1, 2, 4, 6, 7, 8, all normal. But the real key, the magic of the whole system, is in how they handle the numbers 3, 5, and 9. You're going to want to pay close attention to these three.
First up is the number 3. Pilots and air traffic controllers say tree, but why? Well, that soft th sound can easily get garbled or just completely lost over a bad radio signal. But tree, that hard T sound, just cuts right through all the noise, loud and clear. There is no mistaking it for anything else.
Next, we've got the number 5. This one is pronounced fife. And I know that might seem a little strange, but think about it for a second. The word 5 ends with that soft V sound, which, over a radio, can sound an awful lot like the word fire. That's a word you definitely don't want any confusion about in an airplane. Fife, on the other hand, with that crisp F sound at the beginning and the end, is completely unmistakable.
And finally, the number 9 becomes niner. This one's done for two really important reasons. First, it makes it sound completely different from 5. And second, aviation is a global business, and the word 9 sounds dangerously similar to nein, which of course is the German word for no. You can see how that could cause some problems, right? Adding that extra syllable just makes it totally distinct.
So there you have it. Tree, 5, and niner. These special pronunciations are the fundamental building blocks of the whole system. From here, pilots and controllers use these simple digits to build all the other numbers they need, turning these basic sounds into critical data. Let's see how that works.
So the next big rule is to say each digit individually. This means the number 15 is never 15, it's 15. This is brilliant because it stops anyone from confusing 15 with 50. And for bigger numbers, like altitudes, it's just as clear. 1,500 feet becomes 1,500. So what about 15,000 feet? Well, that's 15,000. This whole structure is designed to remove any possible confusion.
Okay, so now we have the basic rules down. Let's put them into action and see how they're used in some of the most common and most critical communications you hear during a flight. This is where you'll really start to hear this language come alive.
First up, we've got the heading. This is simply the compass direction the plane is flying, and it's always given as 3 digits. So a direction of 245 degrees is never read as 245. Nope, it's heading 245. It's simple, it's clear, and it's incredibly precise.
Next up are radio frequencies. Pilots are constantly tuning their radios to different channels to talk to different controllers. And just like with headings, every single digit is spoken individually. The decimal, by the way, is always pronounced point. So 121.1 becomes 121.1. And now let's solve that mystery from the very beginning. Squawk. A squawk code is just a 4-digit number that's assigned to an aircraft. It basically makes the plane light up on a controller's radar screen. Think of it like a temporary digital license plate.
And you probably guessed it, the numbers are said one by one. So the code 4536 is squawk 4536.
Now this is where getting the numbers right becomes an urgent matter of life and death. You see, some squawk codes are universal emergency signals. 7500, pronounced 7500, means the aircraft has been hijacked. 7600 means they've had a complete radio failure, and 7700 signals a general emergency. In situations like these, clarity isn't just helpful, it is a lifeline.
So there you have it. What sounded like some kind of impenetrable secret code just a few minutes ago is really just a simple, elegant system built on a handful of very logical rules. You now have the key to understanding the language of the skies.
Let's just do a quick recap of the core ideas. 1. Always say digits individually. 2. Use the special pronunciations tree, fife, and niner. 3. Remember that the goal is never secrecy, but always absolute clarity. The entire system is designed from the ground up for one thing and one thing only: safety.
So, what about that phrase from the beginning? Squawk 7700, maintain 10,000. It's not gibberish anymore, is it? You've just picked up the foundational grammar of aviation, and now you know exactly what it means.
And that really makes you wonder, doesn't it? What other specialized languages, all designed for precision and safety, are hiding all around us, right out in the open, just waiting to be decoded?